Yeah, now that's okay. I'll be taking you through how to approach a machine learning datathon from a beginner perspective to a more advanced perspective. I would like to ask a question, first of all, to the participants in the meeting. Is there anyone who is a beginner in machine learning? You can raise your hand, you can mute yourself, or you can type in the chat box. You can type in the chat box yes if you're a beginner to machine learning. Nice, I see there's a beginner. Welcome, so welcome to machine learning. I'll just begin my presentation right away. Welcome to machine learning. Hi, Tom. Machine learning is quite an interesting field. And thanks to Zindi, we have in Africa, there's a way to participate in machine learning from a beginner to, there is a new beginner, okay, another one, Precious Nyasuli. Welcome to machine learning. I'll get started right away, my presentation. So one of the myths in machine learning is that people usually think that a lot is needed to get into it, but that's not the case. Anyone can get into machine learning. And another myth is usually that for people in machine learning are usually people in the ICT industry specifically. For one, you can be in machine learning, and it's better to contribute your machine learning or even AI to a specific field. Maybe it could be medicine, agriculture, or any other field. And you can contribute your machine learning to that specific field, not necessarily when you're only in ICT. I hope you guys can see my screen. So for my presentation, I'll share with you, we'll begin with what is machine learning, how to get started in machine learning and some of the applications of machine learning. Then we'll talk about technical approach from position 4 to 6, and then some tricks in machine learning. Specifically, this presentation will be more specific to competitions, machine learning competitions, such as the one you guys are going to be part of in the next few days. So we'll cover some tricks in machine learning to give you an edge over competitors. I believe you're here to learn, and I think it's even better to learn how to win. And then a conclusion. I read tweets a few days ago about how someone was asking, is a conclusion really necessary? Can Trio just stop reading? But I think it's necessary. So we'll also cover that too. So what is machine learning? I would like anyone, if you could unmute yourself. I don't know if I can access the chat box from while sharing the screen, maybe. But if you can unmute yourself and tell me the answer for anyone for the first pattern.
The first one, I think it's you add 3 for each number. It's like a 3 plus 3 gives us 6, 6 plus 3 gives us 9, and so on. The second one, we take off 5. Like 25 minus 5, we get 20, and so on. And the other one,
that's correct, Hitam. And what you're doing right there is machine learning. Thank you for that, Hitam. And hope I'm pronouncing your name correctly. So for the first, as Hitam was still, for the first one, this equation is skipping 3. So for the next answer right here will be 27. So 3, 6, 9, 12, 27. And for the next one, 5, taking out 5, it will be negative 15. That's technically what machine learning is about. What Hitam did, he he looked at the numbers here, found a pattern, and then made an inference from the pattern. So the pattern was each next for each number, after the next number, there is a difference of 3 here. And that's a pattern he has discovered. And then for that, you can make an inference that the next number here will be 27. And that's what machine learning is about. There are a lot of definitions of machine learning out there. And some of them make it seem like it's really complex, but I'll just give a simple one. Machine learning is training a machine to find patterns in data and then give an inference. So you find a pattern in this data, and then you give an inference to the next part. What will it be? So to make a prediction. So for this number 27 that will be here, this is the target variable. This is the target variable. What we are looking for, what we want to predict. What we're using here, these are the dependent variables, and the target variable is the independent variable. And we'll use this in machine learning. We use the dependent variables to predict an independent variable. And then once we figure out some patterns, then we use that to make a prediction. And in machine learning, you just help the computer to find these patterns for a specific of machine learning. For one, there is one where a machine is completely allowed to find its own patterns without being given any instructions, but we'll get to that later. So for this, this is typically how most machine learning competitions are. You're given multiple Excel files, and then they have columns and rows. For some columns, you can the ones that are predicting, and then for one final column is incomplete. A third of one column is usually incomplete, and then you're supposed to find patterns in most columns to predict a third of one column. And so you're given data, make your own and then make your own model that will find patterns in the data and then make a prediction. So it's for competition, it's not that complex. So the complex part is creating your own model, and people do this in different ways. And that's why people refer to machine learning as an art, also besides being a science. To get started in machine learning, you don't need very many things. So of course, for one, you'll need a laptop or a desktop, and then you'll need to install a code editor if you want to use it offline. The code editor could be such as Google Colab or Jupyter Notebooks. You can use that for Jupyter Notebooks, it's easy for when you want to work offline, but for Google Colab is better when you want to work online and you can get extra GPU, just like Lawrence mentioned. He did mention that his favorite is he likes using Google Colab. I also like using Google Colab. You get a lot of benefits that your machine can, even if you have a machine that's not that powerful, you can still get started. And you can make your visualizations. The code editor will allow you to make your visualizations, to test the data, and even create your equations. And then you need the storage. This is not that big of storage, but as I mentioned, the majorly when in competition is just given data, and then you're just supposed to fill a certain column. So for that data, you need some storage. And another thing you notice in machine learning, you create more data from the data you're given. That might need storage if it's a very complex problem you're solving. Like when you're using deep learning, you might need more storage, since even the more data you have for some problems gives more accurate results. And finally, you'll need Google. You'll need Google for your code, for to improve your code, to learn new things, to make changes. You can you can you can try working completely offline without any help from others. But even if you try to think about it, most of the libraries you use when machine learning, they are created by other people. Machine learning itself, for the code editors that you'll be using, was created by other people. So no matter whether you're an advanced data scientist or a beginner, it's good practice to keep learning every now and then. Like for example, you can find something that you find out you already knew about, and you have your code for that to perform a certain function, and you have your code for that. But then later on, you realize there is a simpler way out there. So it's good practice to keep learning, uh, to improve your code, maybe to learn new things. And for that, you'll need Google. In software engineering, people say Google is your friend. And it helps you a lot when you find challenges, and when you want to learn new things. Next, we'll learn about some of the applications of machine learning. And machine learning has a lot of applications, from fraud detection to product recommendation to image recognition. Just recently, due to the COVID-19 pandemic, people started creating models that can detect whether you're wearing a face mask or not, and that's really interesting. Self-driving cars. The richest person in the world right now, currently, uh, has utilized machine learning to make himself who he is, and that's unsupervised machine learning for self-driving cars. For example, unsupervised is when the data is not given labels. So for example, for the numbers we had, the model is supposed to figure out something without much of the without labels on how to perform this inference. There are other applications in almost all fields. In the medical field, such as detecting brain tumors and other diseases such as hypothyroidism. This is a weird disease where some of the symptoms are increased heart rate, uh, heightened bowel movements, and other weird symptoms. But thanks to machine learning, it's possible to detect this. You just need images for people who are already diagnosed with this, and then make a model for this, and you can detect some diseases at an early stage and save lives. So machine learning is a very diverse field and helping in all fields. Image recognition, for example, in Facebook, where people where people are when you post a photo like in Facebook and a group selfie maybe, and you're in that photo, and then if you've in the settings, if you've allowed Facebook to access your data, it can recognize who among those people you are and suggest that you tag yourself, that this is you. And if your friends have allowed that, it can suggest who among your friends is in that photo and suggest for you to tag them. That is machine learning. Product recommendation, such as in Amazon. I'm sure everyone in this meeting has encountered product recommendation in one way or the other. So you've benefited from machine learning. Could be in YouTube when you're browsing music, and after you listen to a couple of songs, some extra songs are predicted to you, are recommended to you. You can try out this song in Amazon, or even if we go more local to Jumia. You put an item in your cart, in your shopping cart, then you get a section you might also like, this and this. Netflix, based on what you've watched, there is something else that you might be interested in. And then in fraud detection, such as detecting fake IDs, fake accounts, A lot of bank accounts use this, especially for online transactions, and even in language translation. Like for Google GNMT. This is the algorithm that translates languages. When you find a foreign language in somewhere, maybe when you're browsing somewhere and you want to know what it means, and you type it in Google, it runs a loading screen and then translates to you. Voila, like magic. This is what this means, and that's machine learning. There are plenty of applications of machine learning, and I'm sure everyone has used one application, whether knowingly or unknowingly, at one point in time. So next we'll get to the technical approach to machine learning. We've learned what machine learning is. We've learned what some of the applications of machine learning are. And now for a computation, more specifically like a Zendik computation or any other application, you can apply this and have yourself a model to predict the third of your data that is missing, or any part of data that will be missing, or even use it to build a model that does more things like any one of these things over here. So for the steps for creating a model, specifically for a computation, would be the first thing you do once you get the data. It's EDA. EDA is exploratory data analysis. By this, when you get the data, you have to go through the columns and the rows. In research, we call columns variables. We also call them features. So when I say a feature, then it means a column in an Excel file. What will be given in simple terms will be a column. A columns, the ones from north to south. When you get an Excel file to use to predict, for this will be, you first go through all the data, each feature individually, each variable, each column, and then you must find out how they relate to the column that you're trying to predict, the variable that you're trying to predict. The variable that you're trying to predict is known as the target variable. So we get into machine learning by first going through the data and then finding how they relate to the target variable. When you find how they relate to the target variable, the things you can search for in EDA is the distribution. And I'm sure at one point or another, even if you're not in machine learning, you've come across the term normal distribution. In machine learning, this is a very important aspect, the distribution of each variable. For example, if to check for something called multicollinearity, that might affect the outputs of your data, your predictions. You must find the distributions of the data. So for example, if you find out that two dependent variables were somehow related to each other. They were related to each other in the form that not the target variable, that one or two columns can predict another one that is not your target variable. And then this might cause a problem, depending on the type of problem you're solving. So for this is one thing you can check for, and you check this by checking the type of distribution that these products these variables are distributed in. Could be a normal distribution or other distributions. And after finding this, you check the target variable. You check the target variable to find out how is it distributed, so that you can find what kind of problem it is. It could be a regression problem. It could be a classification problem. So if it's a regression or a classification problem, then the metric is what we use to measure the answers that you've predicted. To evaluate, a metric is a way to evaluate your predictions. So after looking at the target variable, then you can know what kind of problem it is, and then use this to predict, and then use this to find a metric that will be dependent on the kind of data you have. For classification, there are different metrics such as F1 score, recall, precision, accuracy, and for regression problems. And there are different different metrics such as RMSE, that is root mean squared error, MAE, that's mean absolute error. And you'll choose this depending on the kind of target variable that you have. For a classification problem could be a problem such as whether you're predicting if something is A or B, if a person has a bank account or does not have a bank account. That's a classification problem. If an item, an object in an image is a goat or a cow. So after finding the right metric, then you can then go to create a model. But before then, there is a step right in here between. And for that step is dividing your data. So we divide the data by splitting the data into folds. You split the data into folds so as to avoid overfitting. Overfitting in machine learning is an occurrence that your model could be thinking that it is predicting your data very correctly, but maybe due to the data that you have, this is not the case. When it is given some foreign data, it performs poorly. For example, when you're predicting, maybe when you have maybe 10 images and you want to predict what the object in those 10 images is it a goat or a cow? And 9 out of the images that you've given your model are goats and one is a cow. If your model gets to find out of this, then it will predict in your predictions, it might predict everything as being a goat, and you'll have an accuracy of, if there were 9 goats out of 10 nine goats and 1 cow to make 10 items, then it will have a 90% accuracy. But then when you give it data that has a ratio of maybe 5 goats and 5 cows to test out your model with foreign data, then your model will have a hard time trying to figure out which one is a goat and which one is a cow due to overfitting. That's one of the reasons why you'll need to split the data into folds. You can do this using cross-validation, and this will help simplify the problem of overfitting and underfitting. After you've split your data, you create a model. You initial your first model. Your first model should be a simple model. So guys, feel free to interrupt me at any point if you feel that like I'm going too fast, or I know there will be a Q&A session later, but I'm okay with being interrupted to ask a question. So we've said that you first look at the data, the target variable helps you choose the metric, but the benefit of Zindi is that for most competitions in Zindi, I think all of them, they'll tell you what metric to use. So after you've chosen the metric, you already know what metric to use if you're on Zindi platform. You've done cross-validation, and then you create a baseline model. That is the first model. The first model should be a simple one. After you've created a first simple model, the next step is to add features to it. You'll notice in the approach, the machine learning approach, a lot of it will involve going back and forth between these points. After you've created a baseline model, you would then add new features to improve the score. So maybe in one of the features, in one of the variables, the one that we're using to predict something, you find out that it is the whole column is a square root of something, and maybe you can square it and add that feature to use it also to predict what you're predicting, the target variable. So this, after you've created a baseline model, you create new features. And then after you create new features, you should create, so first of all, you should create those features based on your EDA. So that's why EDA is very important. So you create new features based on your EDA, and then you keep creating new features while checking for the accuracy of the score, until you get to a point where you feel that you've reached the limit of performance for this specific model with feature engineering. So that part for creating new features, that is called feature engineering. And when you get to a point where you've added new features and your model is no longer increasing in its performance is no longer becoming better, then it's time to test out new models. So you've created a baseline models, you've used EDA to create new features, you've gotten to a point where the model is no longer performing better. It's time to test out new models. You test out new models, different models, and then you do the same for them. You after you've tested out different models, you test out feature engineering, creating new features until you get to a point where you found some better performing models. So after finding this out, something else that you do is feature selection after feature engineering. Feature selection is, for example, reducing the features. You've created new features, but you might need to reduce some of the features. For example, in some of the models, like ensemble models, these are boosting models. For example, XGBoost and CutBoost. There is an option where you can check the importance of each variable that is used to predict target variable. And after you've made your prediction and you can find that one variable is not important at all, you can try to take it out and then run your model and see how well it performs. It might improve in accuracy, it might reduce. So at this point, this is where the art is. This is where you experiment. This whole process could be uniform, but for the feature engineering and feature selection, you can try out different methods. That's why it's an art. You can reduce, and for example, you can reduce some features. You can use even PCA for feature reduction to reduce the variables that are not necessary. For example, you can even find out that maybe one of the features is very important in predicting your target variable, but then the importance of the other features from that one is very minimum to compare to that one feature. So you can use that feature to create more features, or you can take it out completely while testing out how well your model is performing. So after you've gotten to a point where you've done your feature selection and feature engineering, by this point, you'll realize that you've found out which models and which features are performing best. At this point, you've found out which models and features are performing best. So you found the best data to use for your prediction, and you found some of the best models to use for your prediction. That's the point. That's the point where you now go to HPO. HPO is hyperparameter optimization. In hyperparameter optimization, this is whereby you tweak your specific model, the one that is performing best or some of the best performing. You tweak the parameters in it. Parameters that are common in models, some such as N estimators and max depth. Such parameters are very important, but they're usually important up to a certain point. Like, for example, there is a point where you can get that tweaking your model any further will not make your results become better. So it's a whole cycle from EDA, and you'll keep getting back to EDA. Some people go to EDA after creating a model, after EDA and metric, after creating a model, that initial model, they go straight to optimizing the model. That is trying to find out the best way that model can perform. But that might not be advisable before you try out feature selection and feature engineering. Since what happens is that you might get to the limit of that model, thinking it's better, and then when you try out a different model after you've already tweaked out your parameters, then the other models might not perform as optimum as they might have performed if you had first done the feature selection and feature engineering before going out to HPO. So that's one of the things. It's better to first try out different models, then finally doing the hyperparameter optimization after you've done all this. So you can just go back through that. You do the EDA, find a metric, cross validation, create a baseline model, fit the baseline model using EDA, what you find out from the data. And then when you get to a point when when the performance is no longer increasing, test out different models, and then test out different features for best performing models. After you found the best performing models and features, now you can try feature selection, removing some of the features, and then now you can squeeze out your model for the best performance. And that's about it. That's how you can approach a machine learning model. If you follow those steps, you'll get yourself to the optimum model, and you'll find that you'll find the best model for your data. Some of the tricks I would like to share with you guys are: one, there is a parameter in most functions known as random state. Random states allows you to run your data, to get the same outputs every time you run your data. So for example, if you're predicting something, and since it's a prediction and you run it different times without setting a random state, you'll get different outputs for both predictions. It might be a difference of 0.001 for both predictions, but when you set a random state, then for each time you run that model with that random state set to a specific number. So your random state is usually set to a number. It can be 0, it can be 1. I see most people using 42. And then you can use your model to find out which randoms to set that your model to get the same outputs each time you run it. Now, the trick for random states is most people, they set a random state for the models, but then they've used different functions in their notebook. But the random states is usually set automatically for most functions. Like it could be 0 for something where you used a very specific way to import your data, and it was set to 0, and you didn't see this. But then when you came to your model, you set the random state as 42, which is commonly used. So you might find out that if you set the random state for all the variables for all the functions that require random to the same number, then your performance might improve. It will improve. And another trick for using random state is when you're running your model, you can this is a part for hyperparameter optimization. You can run a for loop with different random states to find out and to get different results while testing out which random state performs better. So automatically the random state for most is either 0 unless changed to a specific number. You can find out that the difference from 0 to 1 for changing your random state for your model from 0 to 1 could get you a very high difference in your output. There was this one competition on Zindi, and I was positioned that year after trying out different models, feature selection, and then I changed the random state for the models only. I guessed the number, though I hadn't tweaked it to one that I knew of, to one that I was sure of, but I guessed the number. It changed the position from position 30 to position 8. So from that, so you can use, and that's a huge difference. So for that, you can use your random state, check out different random states. Maybe you can run a model under random state from 7 to 14, or even 20 to 30. Since running more times will involve using more RAM. So you need to set like a specific one, check out which performs better. Another trick is for loading data. So in most IDEs, when you wait in the platform for after a few times, then you're logged out of the system. You have to import your data once more. So usually people just import the data, and there is a way, like for example, I like the way Lawrence Marie showed us how you can just you can mount your drive and then access files directly from the drive. There is but for that we'd also have to keep updating every time you would be kicked out of the session. There is a way, if you still the same way, an implementation on mounting your drive. So you can mount, instead of mounting your whole drive, you can use a function to load your data, to give access to that specific function, to that specific file from your drive. That way, every time you load your data, even if you are running your Colab from a different laptop and your data is not in that laptop, then you can access it directly from your drive. I will share the code for anyone who wants the code for that. I can share it, but you can check it out I'm sure if you search in Google, in any search engine, you'll find a way to extract a specific file from your drive without having to load it every time you're running your data. And that's it for me, guys. I hope you've learned something. And in conclusion, I can say that this predicting the future isn't magic. It's artificial intelligence. Though it's a lot of art and trying out different ways, it's not magic. It's artificial intelligence. And anyone from a beginner to an intermediate person to an advanced data scientist can find a way to get into machine learning and make a change to the world. Thank you, guys.
Thank you, Ted. So I would love to give this chance to Perez. I know she was not able to make it during the first round. So maybe I'll just give you this chance and just take 10 minutes or so. Yeah. So I hope you're ready, Perez.
Hi.
Hi.
Yeah, I'm ready, and I'm really, really sorry for the problem that I faced before.
It's okay.
So I hope you can see my screen now, because I think we are really, really running short of time. I'm just going to make this really short and focus on what happens during the competition, based on my experience from our past Umojahack. So the first thing that usually happens in the morning, you have a session, and you'll have Zindi ambassadors and officials taking you through the different challenges that are available. Rose already told us that there's an intermediate, there's a beginner challenge, and a more like advanced challenge. So in the morning of the hackathon day, you'll have different people take you through the different challenges, what they are basically all about. And also if there is a starter notebook, you'll have somebody take you through the starter notebook just to help you jumpstart and not like maybe just write code that, it's not really that important to the competition. And so a few tips. Before the competition, you'll see, like, if you can see my screen, here you see, like, for this one, we have tags, customer service, telecom prediction structured. So the competitions are ready. I think they've already created the pages for them right now. So you can just go and look at the different competitions and then check which tags. So if they tag like telecom or prediction structured, go look at similar past challenges and then try to just practice with them. And for last time, I think for Umojahack Africa, they sent an email with also sample like challenges that can help you prepare for the specific challenges there. So yeah, you should maybe take a look at them and practice so that by the time you get there in the morning, you are set. And also another thing that you can do is maybe write code for things that will almost likely happen, like EDA code, building like different models. You can just have those things ready. You're just waiting to adapt them to the specific challenge that you have, because there's a hackathon and it's usually like a time one, and it's a lot of pressure and a lot of things can go wrong, like internet on that day or your machine. So you need to make sure you're utilizing your time really, really well. So things that you can do in advance, like data for code for loading the data, prepare for that, make sure you have them somewhere so you can just copy and paste, and all you need to do is make a few changes. It also just makes you confident. And then on the page, this was the one that you had. So you can just like go through and read the description to make sure you understand what you are expected to do. The discussion that you'll be having in the morning, I hope that doesn't change this year. We'll also like expand everything for you and you'll have a chance to ask questions. But then again, it's just good to come back and read and understand what you're supposed to do. And something that is really important, you'll go through. So there's the info, which is just general about who is organizing the competition, who is supporting it, and their mission. And then the data part is just, okay, so these are what you have, and this is what you can, you're going to use to train your models. It's really important to read this part. Yeah, especially when they have things like variable definitions that can help you with feature engineering. So do not ignore variable definitions because you're not going to feed it into your model. So just like download them and look at them and make sure you understand. And then there's the evaluation. I think this is really important because eventually this is what you're going to, that's what is going to determine your position. So you need to know, okay, what is the evaluation metric for this? I think the previous speakers have talked about some evaluation metrics, and it is really, really important to know which one they're using. Like for maybe classification, there are different metrics for that. So just know which one are they focusing on. Is it accuracy? Is it F1? So just know, because that is what will also determine, for example, what you're going to use as your evaluation metric when you're doing your validation. Yeah, and also knowing the format for the submission file, because it will be really sad if you went through the whole process of building your model and your results are looking good, but then you can't be scored because you are not able to submit. Hopefully if they provide a starter file, and mostly when you go to the data, they usually have sample submission, so you can take a look at it and see how it looks like, and that can also help you arrange your submission in a format that is accepted. Yeah, so, and then there's this part for discussions. Always be on the lookout for this part because people mostly like somebody has found some interesting data set that can help you improve your score, or some discussions on things that are not quite clear, or maybe some tips. You can just like look here, and I found that sometimes just if you ignore things, then maybe somebody shared something that boosted everyone else, so you're going to be disadvantaged. So do not ignore this part. And I think my final one for this, the website will be on the submissions. So on the submissions, what I'd say is, this is how it looks like, first of all. What I'd say is for the submit as many as you can. For the last, the Tanzania Turing prediction one, my winning solution was never the solution that was the best when we had the private leaderboard. So I was actually shocked. It was not among my best submissions, but then when the public leaderboard was revealed, it was actually the one that took me to the top. So you're going to have limits, of course, on how many submissions you can make, but submit as many as you can, because you can never know which one is going to be the best one when the public leaderboard is revealed. And don't get, for example, when you are doing your own validation, you find that for this submission, I ran this and this run was like, it was really, really low. Don't just ignore it. I'm sure running your model, it took you some time, just submit it, you never know, because even for that one, it was like, this score is not that good. I was almost not going to submit it, but I was like, hey, it took me some time to do this. Let me just submit, and it actually ended up being my best submission. So yeah, I think that's it for this page. And I can just show you the solution. So for this one, it was the beginner one, and we were given a starter code, and so I built on top of this. Yeah, so I think the previous speakers have talked through the whole data science pipeline, the whole process. So you load the data and try to see how does it look like, what kind of data types do we have, what are we dealing with here. And so you can use functions like info to just see this is what I have, and also just take a peek into the test set 2. And then missing values is something really important, and for you to know different like features, what percentage is missing. For some algorithms like I think XGBoost and some ones, you can ignore missing values and let it handle it for you. But for others, it's really important to know which ones are missing and find out the best way to kind of take care of the missing values. And then just describing, just knowing the columns which are not numbers. And then in this part is more like doing visualizations. They just help you to see how can you see like what it looks like, the trends, and also it can be really important in creating other newer features in like feature engineering, like Ted talked about earlier. So this is just some visualization, and then you get to this other stages. Like now, I think I want to now do some advanced feature processing and then build some models. So I think for this part, the thing that I did that made a difference was encoding the categorical variables, and I chose the mean encoding method, and it really did make a difference. I think that's what eventually took us to the position that you were in. So it's a very interesting technique. It's something that you can look up. So, but the basic idea is like trying to just leak some information. Yeah, so you're trying to, instead of assigning your categorical features like random values like 1, 2, 3, and 4, you're trying to give them values based on your target. So that's why it's called mean encoding or target encoding. And in the process, you find that you are leaking some information from the target, and that makes your model stronger. So yeah, so that was just basic, and then you create a pipeline. You put the pipeline together, and then you run. And then here there was something. So it was a classification problem. So a confusion matrix here can help you, and especially because it's classification and the different evaluation metrics that you have. So just look at how those things can help you improve during your different iterations. So, and then there's this part where for this particular challenge, we really had little data. So even though I divided the train data into the validation and train set, I had to combine both of them and train a model, the model after hyperparameter tuning with the whole train set. So depending, it might work, it might not work, but you just don't just like say, okay, the model that you built with your split train set, that's what you're going to use. Try also, especially if you have very little data, and data is really important here, try and combine both of them, your train and validation set, and see if that can help you build a better model. So I don't know if I've exceeded my time, but that's basically it. If you have questions, I think we have a panel discussion, or you can just type them on the chat box. Thank you.
Thank you, Perez. Also, thanks to our speakers, Azza, Ted, and Lawrence. That was amazing. So yeah, this is not just for the hackathon, but also for you to scale up in your careers in data science and machine learning, yeah? Never stop learning. That's the thing. So I will take this chance to call upon David. He will be taking us through the panel discussion, that's the Q&A. So welcome, David.
Okay. Hello once again, everyone, and thank you so much for the great presentation. I really liked it, and I really like the idea that we don't really need that to be in the field of ICT to participate in these competitions. We just need to believe in ourselves, and so that we can be great in these hackathons. So I took a question from the chat that was regarding the Zindi or either the Umojahack questions. So I took one from the chat, then the rest were answered on the chat. So the answer that I took were presented to the panelists. So then the rest are like 3 questions. I thought they were helpful for the participants to know more about. So I'll give each, because of time, I'll give each panelist a question to answer, so that they can take 2 to 3 minutes and answer the questions, so that we can try to wind up the session as early as possible. So the first question will go to Lawrence. So what type of problems or challenges should one expect in the hackathons or in the Zindi challenges, like problems to expect, especially as a beginner? Then the second question, I'll post it to Azza. I hope, Azza, you can hear me. So how much similarity is there between these competitions and the real world projects? How similar are they the Zindi competitions and also with the real world projects. How similar are they? Yeah, so that's for us. Then for Ted, I'll pose this question to you. I hope it will be of help to participants. Have you ever been demotivated after starting a competition and failed to complete it? If yes, how did you approach that problem to get where you are now? So I hope you got that. And then the last question will go to Perez. How can someone overcome imposter syndrome, especially at starting the Zindi competitions at the starting point? How can you try to overcome imposter syndrome to try and be part of these competitions? So I hope each one got their question. So we'll start with Lawrence, then Aza, then Ted, and then finally Perez. Yeah, thank you.
Okay, thank you for the question. So the question is, what kind of challenges do you expect on the Umojahack? So from last year's experience, we had 3 challenges. So the first one was the beginner challenge, was a regression challenge, I think, where we were supposed to predict the area that got burnt in DRC Congo. The second one was a classification challenge, and the third one was a computer vision challenge. So similarly to this year, I think we also have 3 challenges. So the first one, it looks like we have a classification challenge as a beginner level challenge. We also have the Insta-Deep challenge. To me, looks like it's a computer vision challenge also, and also a third one, which most probably is a classification challenge. So you expect the 3 challenges, or the beginner one is the easier one. The advanced one is a deep learning challenge generally. So you can also look up on the Zindi page. You can see, although for now you don't have much information about the challenge, you only know at least there's a clue on the beginner challenge, because they are saying predict if someone can do something. Looks that is a classification challenge. So, but you cannot get access to data for now until that day till 27th March. That's next, I think, a few weeks from now.
Okay. Thanks for that, Lawrence. At least now we have an overview of what we expect from the challenges. So the next question will go to Aza. Please, Aza, if you are there, you can take your question. Thank you.
Thank you, David. Okay, so I think competitions are the most easiest way to know what is to know the real life problems. So 1 year before, I don't know even what is machine learning or how to apply it. When I participated in the Umojahack, I finished in the last places, and I don't really know what is about machine learning. So but it was an initiation to me to know the existence of some what we call machine learning, and how we can benefit, and that machine learning, we will benefit from it in the future in many applications. So I started with the event of Zindi Weekends. This is a weekly hackathon that every weekend Zindi hosts an hackathon with a different application. Sometimes it's a regression, sometimes it's computer vision, sometimes it's NLP. So it was a chance for me, and for many competitors to know how to what is NLP and how to apply it, and what are the applications of those different fields. So when you start an hackathon, you will you will really work hard and search. And when you search, you will find other applications that are related to the topic. let's say you will participate in an hackathon of NLP. So you will find a lot of applications when you just type NLP and you want some code or you want to know how to approach your problem. So you will find a lot of applications during research, especially when you start searching. So you will you will read some articles, so you will read some blogs, and in each blog or article, so the introduction will give you an overall. You will see this field from other visions, and you will see the applications, and you will know other applications. So I really encourage our attendants to participate in every event. When you see that Zindi posts that there is an hackathon, enroll in this hackathon, and with time you will be such an expert. As I said, last year in this time, my first Umojahack, I finished it in the last places. Now I am top 11 in Zindi. So nothing is impossible, just work hard and you will do it.
I think the next question was mine.
Okay, it's okay. Yes, Ted?
So my question was, have you ever been demotivated to finish it?
Demotivated, yes.
And how did I go about it?
Yes.
Yes, I have ever been demotivated from finishing a challenge, and it was an image processing challenge, and my challenge, the main issue was I couldn't get a submission, so my progress couldn't appear on the leaderboard since none of my submissions went through. There was one file that had something missing, and it was quite frustrating. But I really like how Zindi has a discussion platform, and that is what helped me. So I reached out to someone, and there was a lot of help on how to do this. And these days, I don't think such a challenge can appear since Zindi. That was a while back, since Zindi includes a notebook on how to get started. So I did, but I overcame this by reaching out to those who had already gotten there.
Thank you, Ted. The last question will be to Perez about how to overcome imposter syndrome. I hope you remember your question, but that's what it was talking about. Yeah, maybe we can just finish with you.
Okay, that's a really good question, and a somewhat hard one. But what I can say is that I think one way to do it is like before the day of the competition, do like a lot of practice with similar competitions. The more you progress, it will make you like feel more confident and better prepared. And then on the day of the competition, I think from my experience, what usually helps me is that I do not let like the different because a lot is happening at that time, and since this is a hackathon, it's something that is timed, and it can be so much pressure, and immediately like you find that after maybe 30 minutes, the people already on the leaderboard and they're having like really good scores, and you probably not have been able to even generate a baseline model. So I actually try to tell myself that I can do it. Whatever is on the private leaderboard does not necessarily mean that is what is going to be the final score on the public leaderboard, because the public leaderboard is what eventually matters. So there's still some hope for me. And then imposter syndrome is something that I think almost everyone battles, even if like you're an expert. You still have to kind of like struggle with it, but just believing in yourself and also not putting so much pressure on yourself. It's beyond being a competition where you probably want to be the glory of being at the top or the prize money. It's also like a learning opportunity. So if you take a more relaxed stance, like, okay, I am here to win the prize, but I'm also learning in the process. So the only thing that I've been getting out of this is not just the prize. So it's not the winner takes it all, for example. And me just doing that, the experience that I'm getting from this competition will help me in future competitions and future work. Kind of like just boost your confidence and your motivation. Yeah, but I think if you just like keep practicing and do many competitions, so you in the next competition you'll be more confident and imposter syndrome won't be much of a problem to you. So it's something that is a process. You don't just wake up one day and you're like, hey, I beat imposter syndrome, but it's something that if you keep working on, you can beat it. But the most important thing is just to believe in yourself and that you are gaining. It's not you either win or lose. You will still gain something out of it. I hope that was helpful.
Thank you, Perez. And also many thanks to our speakers and the audience for joining us in this session, hosted by Alliance4ai in collaboration with Zindi. So I'll just push this to Alex just for some final remarks, and then we can end the session. Thank you guys for coming. Hope you've enjoyed. Hope you've learned a lot. And I also hope you've scribbled some short notes. Yeah, thank you guys.
Well, guys, my computer froze for a moment. Thank you so much for spending all this time with us. You spent about 2 hours, if not more. I hope you've learned a lot. We'll post these recordings to Twitter. So follow us at Alliance4ai so you can get the link on Twitter, right? It will be on YouTube. We'll post a link to it. Probably cut the video into different parts so you go to the part that we are most interested in. After this, remember, the deadline is today. Sign up your university so you can compete. Create your teams. I believe teams are about 4 people. So find 4 people you want to team up with for different challenges. Maybe in your university have people that would do each of the 3 challenges, right? So split up into teams, form those teams. Please use the Google Sheet I shared. Write your name and your team down so we know who you are and who is competing. And we can follow up, and there's so much more that we can share and you can learn. With that, continue competing. Good luck. Let us know how it goes by messaging us on Twitter or LinkedIn. And till next time, enjoy the rest of your Saturday. Goodbye.